Hi guys, we're going to do 7E in this lesson, which is integration with trigonometric identities, sine and cos, and also tan. So let's get happening with that, okay? So there we are, that's the title screen, and off we go. Now, for integrating sine and cosine, where we have this form, the integral of sine to the mx times cos to the nx, where m and n are zero positive integers, guys and gals. Now, here's the deal. If either m or n are odd, in fact, if either of the index is odd, then we use what's called the odd technique, okay? However, if everything is even, m and n are both even numbers, including 0, we use the even technique. In other words, if you had sine squared and no cos in there, or cos to the fourth and no sine in there with respect to x, you would use the even technique. Now for the odd technique, this is what you do, guys. This is the Wolfie recipe. You pick out the odd function and you combine it with the dx term, okay? Then you make the other one, now what do I mean by that? You make the other function u. In other words, if sine is odd, you make cos u, and if cos is odd, you make sine u, okay? And then you use variable substitution with u to anti-differentiate. It's an ingenious technique, and I'll show you. However, if we're doing the even technique, guys and gals, we simply use the double angle formulae. Sine squared x equals a half bracket 1 minus cos 2x, and cos squared x is a half open bracket 1 plus cos 2x in order to solve them, okay? To solve them. Now I'm going to do some examples now over the screen. Okay, we're trying to find the antiderivative of the following expressions: sine squared x over 2 and cos squared x over 4. All right, let's go for that. Sine squared x over 2. Now that's even. Can you see that? It's squared. So therefore it is even, and we're going to use double angle formula, which means we will get a half of 1 minus cos x, where x is double what this one here is, the x over 2, okay? So that's easy to integrate. We just get a half of x minus sine x plus c, okay? There we go, guys. Now this one here is also even, but it's x over 4 and it's cos this time, cos squared x over 4 with respect to x. Again, we use double angle formulas, and what are we going to get there? Yes, we're going to get that beastie, okay? Let's just look at it. So it's a half of 1 plus cos of x over 2, where x over 2 is double that x over 4. So now you think in your head, what's that going to be, guys and gals? It's going to be, you ready? Half of x plus 2 sine x over 2 plus c, yeah, for you and me. Very good. Now let's do the next one now. Evaluate the following indefinite integrals as functions of x. All right, now this number a, there's actually 3 ways of doing that. There's 3 ways, actually. This could be evaluated using the trig odd technique. Yes, now both of those functions are odd. Sine is odd and cos is odd, so we could take either of them out and combine them with the dx. It doesn't really matter which way we do that. We could combine the cos with the dx or the sine with the dx. It really matters not in that case. Or we could use original plus derivative both present in the same integrand, which we have already covered the theory in a previous video. Can you see that? See, cos is the derivative of sine, ladies and gentlemen, so you could do it that way. And you can also use double angle formula, because that integral equals a half of sine 2x with respect to x. So that's actually got a smorgasbord of options that we could use, okay? But we're going to use the odd technique because this lesson is about the trig, you know, odd and even technique. So we'll use odd. So we'll combine the cos x with the dx and let u equal sine x. And what do we get? Du dx equals cos x, and therefore du is cos x dx. And now let's go for the old u switcheroony and switch. Oh, look at that. So u was sine x and the du is the cos x dx. Now, isn't that like a miracle? So amazing. And it's so easy to anti-differentiate that. It's simply a half u squared plus c. Then we have to substitute back for what u was. There it is, sine x. So it's a half sine squared x plus c for you and me. Quite marvellous, isn't it? Right, now what's this beast doing? Looks nasty. I think what we need to do, once you develop an eagle eye for these things, which you will after you do a bit of practice, quite a bit of practice, it's going to be that. See, that is 2 sine x over 2 cos x over 2 all squared. And the reason I'm saying that is because now I can do, that thing is a double angle. See, that is actually sine of x all squared, yeah? See, inside the bracket is the double angle, is sine of x. See, now we've got that thing there, we'll just double angle that again, and you get that. My goodness, yeah? Pretty amazing. Now, that's very easy to anti-differentiate, isn't it? It's basically a half of x minus a half sine 2x plus c. Wow, pretty good, yeah? Okay, next screen. Anti-differentiate the following. Cos cubed x, that's an odd one. Cos x sine 2x, well, that's a little bit strange. And cos to the fourth of 2x and sine cubed 2x, that looks like a lot of work. However, none of them are difficult. Let's go for this one. That is a clear candidate for the odd technique. Wouldn't you say? Definitely. So we take out one of the causes and we put that with the dx, and then we say that u is the other cousin, which is sine x, yeah? Okay. So there it goes. U is sine x, therefore du dx is cos x and du is cos x dx. And now I think we're ready to go now for the old u switcheroony. Oh, yes, look at that. See, that's the integral of cos squared, which is 1 minus sine squared, because I called this thing sine squared. So there, see, that's how beautiful this technique is. Now we're 1 minus sine squared x, and this is going to be just, of course, this is going to be my du, you see, because where are we? See there? Yes, so this is 1 minus u squared du. Okay, isn't it beautiful? Yeah, there it goes. Now that's very easy to anti-differentiate. It's like a miracle, isn't it? It's absolutely ingenious. So that's u minus a third of u cubed plus c, then substitute back for what your u was, which was sine x. And Bob's your uncle. There you go, look at that. Now that was pretty easy, wasn't it? If you know that you have to use the odd technique, it is. Okay, what's next on the agenda? Well, I think, guys and gals, we need to do a bit of surgery on this. We need to call that, use the double angle formula. That's going to be 2 sine x cos x, because we want just all x's, not x's and 2x's and all that stuff. Okay, now what does that do to us? Does that give us a headache? No, not really. Let's just reorganize that. Now, you see, what have we got? We've got the odd technique, you see. Actually, we could do this also, this one as original function plus its derivative, because that could be your original function, that could be your derivative, if it's a minus, which we can easily organize. But you can use the odd technique as well, because that's odd, even though that's even. If any of them are odd, you use odd technique, guys. Okay, so we'll use odd. Right, so therefore, what are we saying? We're combining the sine x with the dx, and we're making cos u. Okay, there you go. That's the rule. Now, du dx is minus sine x, du is minus sine x dx. So now we're going to manipulate that so that we've got a minus sine x dx, and we'll put a minus sign out here so that we haven't changed anything. There you go, look at that. Pretty marvellous. Just a sec while I move myself, guys. I hope you're having a good time. I reckon this is great fun, personally. It's just such a lovely technique. Now, I think we're ready to go for the old u switcheroony now. Yes, look at that. Do you agree? Because this is u squared, this is du, and look at that. It's so marvellous. See, so it's minus 2/3 of u cubed plus c, and u was cos x, see? Pretty nice, very nice. Okay, next screen. Let's see what other fun we can have. Oh, that doesn't look like much fun. It's an algebra ordeal, but hey, we can do it. We can do it. So what would we do, ladies and gentlemen? I think, well, again, you could even use original function plus its derivative for that, because that could be cos 2x could be original function, and minus 2 sine 2x would be your derivative. But let's do the proper trig techniques, because that's what I'm trying to show you here. So, okay, this is even, that's odd. So we have to use odd technique, which means we take one of them out and combine it with the dx. There it goes. There, you see, just like that. And we make the other one, the other cousin, u. So that's going to be u to the fourth. That's going to be 1 minus u squared. So there's 1 minus cos squared 2x. And then that's going to be the, well, that's sort of du, except it needs a minus sign. See? That's what you do. So easy, so easy. Easy peasy lemon squeezy. So du dx is minus 2 sine 2x and du is minus 2 sine x dx. And let's just do the old manipulation throughout the nation. We get this here, and we've got that minus half out the front. Now we're good to go with our u switcheroony. Oh, look at that. Minus a half of u to the fourth times, this is 1 minus cos squared 2x, so that's 1 minus u squared, and all this BC over here is your du. Now we'll multiply out that bracket. Yes, very nice. Now you know what to do now. Come on, it's very easy. It's just minus a half of 1/5 of u to the fifth minus 1/7 of u to the seventh plus c, like that. Now we just substitute in for what u was. It was cos 2x, wasn't it? There you go. Oh yes, I've just multiplied out the bracket. All right, that's good enough. And there it is, you see? It's amazing. That's what it is. I hope you're excited. I hope you're excited because this is exciting, this stuff. Now we're going to do some Tan the Man in the next installment. So I'll see you soon.